All right, we're going to actually put 10.5 and 10.6 together. I'm going to put them together so there's just one set of notes. They're both solving trig equations. It was just, I guess, a lot. And we're not covering everything in these sections, so let's just say that. So what we're covering from these sections is just a snapshot from both of them. All right, so I'm just putting them all together. So we literally are just going to solve some trig equations. So let's get started with that. Here's example 1. And we'll start here with 10.5 and then we'll obviously go to 10.6. I have 2 sine x minus 1 equals 0. Now, I have two parts here. I am first going to figure out what my answer is over the interval from 0 to 2 pi. And then the second part is going to be all solutions. Okay, so whenever I'm looking at this, we're going to start off solving the same way, but then the question's going to be how many answers are we going to end up having? Just like you solve any other equation, you're going to isolate the variable. And in this instance, I have it as sine x. So I'm going to add 1. Oops. So 2 sine x equals to 1. Divide by 2. So sine x is now equal to 1/2. So if I'm just going over, so sine is positive 1/2. We know that sine are the y values, right? So then I want to look at this and say, okay, if I'm looking at my unit circle here, my y values are positive going up, and it's going to happen. That's not a very good graph. Sine, it looks more down here like this, because it's our pi over 6. Because I'm going from 0 to 2 pi. Oops. That's the kicker, 0 to 2 pi, so I know this is going to be in radians. So this is the coordinate point, square root of 3 over 2, 1/2. This, 5 pi over 6, is going to be the coordinate point of negative square root of 3 over 2, but still positive 1/2. So my positive 1/2 for the sine is the kicker. Now, why isn't it going to be down here? Yes, because my sign is going to be negative down there and my problem says positive. So for part A, x now equals a positive pi over 6 and 5 pi over 6. All right, because it's just going to be those two values. Now, here's the key. Sine is a periodic function, right? So for part B, whenever I want to say for all solutions, what I'm actually looking at is, okay, for this sine function that's coming around here, everywhere it's going, I'm going to hit 1/2, right? I'm just hitting this every single time as I'm going around through there. So everywhere that y here is positive, then it's hitting. Bam, 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 over and over and over again. So if I'm looking at this, every time also right here, we know about coterminal angles. So if I have this pi over 6, I'm going to swing it back around. There's coterminal. Swing it around, coterminal. Swing it around, coterminal, right? That's what's going to send me on this periodic function over and over. So if I want to see for all solutions, I'm going to say x here is equal to pi over 6 plus 2 pi k. And then you have to define k, where k belongs to the integers, right? And we've talked about this symbolism already. K belongs to the integers. I know that that's going to be 2 pi. Every single time I wrap it around my unit circle, I've got another one. I've got another one. And that's what's going to hit here every time, right? On this upswing, on this upswing, on this upswing, on this upswing. That'll be my pi over k. However, I still have this 5 pi over 6 too. So I have 5 pi over 6 that is also a periodic. And then we can set that up. You have to define k here because it has to be an integer. So specifically that integer, right? And then we know that that means belongs to. So same thing as our notation. And that's where we hit, okay, no problem. I got my 5 pi over 6. I got my 5 pi over 6. Bam, 2 pi. Bam, 2 pi to get to the next one, right? Same thing here. Wow, one step around, another step around, another step around. And that's going to have us set up. All right? Okay, let's do another one. We're not doing any inequalities. We're only doing equations here. So let's try this one on. Here's example 3. Sine theta tangent theta is equal to sine theta. And I'm going to say that this is over from 0 to 360. Notice 0 and 360 happen at the same place. So you have a bracket on 0 and it's up to, excuse me, up to 360, but not inclusive. All right. Now this one's not just give it to you straight up kind of situation. Here I have a sign on both sides of my equal sign. So I need to collect those. Just like you do with your x's, I need to collect those. So I'm going to subtract the sign from both sides. Sine theta tangent theta minus a sine theta. Now you can't split apart the sine and the tangent. You're not just subtracting one off of that because these are two actual functions, right? But I can factor. Right? Check that out. And we can use the zero factor property. Once you factor out that sign, then I can set each one of these equal to 0. So sine theta equals 0 and tangent theta minus 1 equals 0. Then I can solve for that. I know I'm going from 0 to 360. So tangent theta is equal to 1 when I add that over there. Because that's what my problem tells me. I want to know where is sine equal to 0. Over here at 0. Because that's my point, right? 1, 0. And then my point over here at 180, because I'm talking about degrees, is negative 1, 0. So theta is 0 and 180. Tangent at 1, now this is positive 1. Where do I have that? Good, up here at this 45 degrees, I have that square root of 2 over 2. And that takes it for tangent. But is that my only one? No, good job, right? Because if I'm also coming down here, this is negative. And negative, right? Negative divided by a negative is that positive. And this one is at 225 degrees. Good. So watch out for that. And this one doesn't say all here. It just gives me that specified unit. So I need to make sure that I'm working just within that specified unit. All right. Okay. Good. Here we go. Questions on that? Okay. You may write them down if you do. Write them down if you do. Okay, so let's do the next one. Example 4. We're going to solve this, and we're going to go between 0 and 2 pi. Solve tangent squared x plus tangent x minus 2 equals 0, and for 0 to 2 pi. What is going on here? Yeah, we get to factor. Factoring never goes away, guys. Never, ever, ever. Which is awesome. So we totally get the opportunity to do factoring here. Well, let's do it right now. I know that this is going to be tangent times tangent, right? The minus in the back here, I know my signs are going to be opposite. One's a plus and one's a minus. I know I need a positive 1, so I'm going to have plus 2 and minus 1. So we break that up. Tangent of x plus 2 is equal to 0. Tangent of x minus 1 equals 0. Well, what happens right here? If I have this inverse tangent of x, is negative 2 a common thing that we know? No. So you can go through here and you can do inverse tangent. So inverse tangent of negative 2, right, is going to give you that value. Plug that into your calculator. And you come up with about negative 1.107. Look at my criteria. I only want the values between 0 and 2 pi. Remember, inverse tangent is on that right side, so I can have negative values. But that's not what I'm looking for here. My criteria specifically says between 0 and 2 pi. So this is outside my 0 to 2 pi scenario. So then that is not a valid answer. Come over here. Tangent of x is equal to 1. So I know where is my tangent of x equal to 1. We literally just did that over there with my degrees. So I know that this is going to be at pi over 4. And down here at 5 pi's over 4. So x is equal to pi over 4 and 5 pi's over 4. This is restricting in my domain, so we can only go with what we have in those restrictions. So what did I say was super important that we had to learn and was definite? Unit circle, folks. What are you seeing right now? Unit circle, folks, right? That makes an impact. So I want to make sure that we're seeing this and we are getting that impact squared away. Okay. Let's do one more here. Here's example 6. Sine squared x plus sine x minus 6 equals 0. Yeah, we do. We totally get to factor again. That should make you happy. Let's do it right now. I have sine of x and sine of x. With a minus in the back, I know my signs are different. What multiplies to give you this negative 6 and adds to give you a positive? Yep, positive 3, negative 2. Split it up. Sine of x. Oh, I forgot to put my interval. This is over my 0 to 2 pi situation. Okay, sorry. Sine of x plus 3 is equal to 0. And sine of x minus 2 equals 0. So sine is equal to a negative 3, and sine is equal to a positive 2. Anybody else see an issue with that? Where does sine go to? Yep. Without any kind of transformations, just straight up sine by itself, am I ever going to get an output of 2? Nope. Am I ever going to get an output of negative 3? Nope. There is no such thing. This one is a no solution. All right. So I feel like whenever we do this, we're just kind of taking all of our information and we're kind of smashing it together. We have to know information about unit circle. We need to know our factoring. We need to know our concept of our inverses. We need to know